In this example, we'll solve three different equations of varying complexity. In each expression, I'm going to take the following steps. I'm going to simplify the left and right side of the equal signs. To simplify, I may apply the distributive property. I may combine like terms. I'm going to write the acronym CLT to represent combine like terms. I also may use multiplication to eliminate fractions. Once both sides are simple, I'm going to add zero pairs. To separate all of my terms that have variables from my terms that are constant, meaning those terms that only have numbers and do not have variables. My last step is going to be to use multiplication or division to simplify or to isolate the variable. I use an asterisk to show multiplication so that my dot that you would normally use doesn't look like a period since I'm giving notes. You're welcome to just write a dot. All right, so I'm going to use multiplication or division to isolate. So let's take a look at this first example. My first step is to simplify both sides of the expression. I see grouping symbols and I see this subtraction. There's a couple of ways to think about this step. When I have subtraction of a group, it's the same as writing -1 times that group. So this equation could be written as 8 plus -1 times -9n plus 2, and that would still be equal to -n plus 2. Since I can write this as multiplication, I can apply my distributive property in order to distribute my -1. I could also think of it as subtracting every term in the group. I'm going to subtract my -9n, and I'm going to subtract my +2. When I do that, I get the same answer, whether I'm thinking of it as distributive property or I'm thinking of it as subtraction of a group. I get the number 8. -1 times -9n is +9n. We could also think of subtraction of -9n as adding 9n. I also get -1 times 2 is -2, or 8 subtract +2 is the same as 8 minus 2. I bring down the rest of my equation. Next, I'm going to combine like terms because I have two terms that are constants on the left side of the equal sign, 8 and -2. If I combine 8 and -2, I get +6. My next step, because these are both simple, there's no terms to combine, I cannot combine my 6 plus 9n because 6 does not have an n term. I can only combine terms that have the exact same variables and also the exact same exponents. On the right side of the equal sign, I have -n plus 2, which also can't be combined for the same reasons. So my next step is to separate my number terms from my variable terms by adding zero pairs. I want to eliminate one of my variable terms from one side of the equal sign so that I can combine it with the term that has the same variables on the other side of the equal sign. I'm going to start by combining my 9n and my -n by adding n to both sides of the equal sign. I do this, I like to add the term that has the smallest coefficient if I can. -1 is smaller than 9, so that's why I made a zero pair with my -n. My zero pair, I call it that because when I add negative n plus n, I get 0. So on the left side of my equal sign, I have two terms that can combine. 9n plus n is 10n. So what I get on the left is 6 plus 10n is equal to 0 plus 2. I'm just going to write 2. So now I have all my variable terms combined, and I need to combine my constant terms. On the left side of the equal sign, I have both constants and variables. I'm going to add a zero pair of -6 to both sides of the equation, so that on the left, I get my zero pair because that's where I want my constants to disappear. On the left, I just get 10n, or 0 plus 10n. On the right, I get 2 plus -6, which is -4, or 2 minus 6 is -4 either way. Last but not least, I'm going to divide to isolate. What I want to do is figure out what operation is happening to n, and I want to reverse that operation using an inverse, using the division instead of multiplication. Right now I have 10 times n, so I'm going to divide the left side of the equation and the right side of the equation by 10. I do that because 10 divided by 10 is equal to 1 whole. 1n is equal to -4/10. 1 times n is just n. And -4/10 can be simplified if I divide the top and bottom of this fraction by the common factor of 2. -4 divided by 2 is -2. 10 divided by 2 is 5. So my final answer is n is equal to -2/5. Now we'll turn our attention to number 2. I have another equation. In this case, in order to simplify the left side of the equal sign and the right side of the equal sign, I have several different approaches I could use. I could either combine like terms. Y/4 plus y/5 can be combined if I get a common denominator between 4 and 5. However, since I have fractions all across my equation, and fractions tend to make me very uncomfortable, I'm going to eliminate fractions here by multiplying every single term by a common denominator. A common denominator in this case can be gotten by multiplying all of the different denominators together, 4 and 5. So I'm going to multiply every single term in this expression by 20, which is a common denominator. So I'm going to get y/4 times 20, plus y/5 times 20, equals 9/5 times 20. Every term on both sides of the equal sign gets a multiplication. Now I can think of this as multiplying by 20/1 if it helps. I can cross cancel. 4 divides into 20 5 times. 5 times y divided by 1 is 5y. Next, y/5 times 20. I can do the same process. 5 divides into 20 4 times. 4 times y divided by 1 is 4y. On the right side of the equal sign, 5 divides 20 4 times. 4 times 9 is 36. So I have a new equation without fractions. I'm going to continue to simplify the left side of my equal sign by combining like terms. 5y plus 4y is 9y. On the right side, I bring down my 36. I have no zero pairs to add or subtract because I already have all of my variables separated from my constants. The left side of the equal sign just has 9y. The right side of the equal sign just has 36. So I can skip step 2 and move directly to step 3. Isolate the variable using multiplication or division. Right now, the left side is 9 times y. I'm going to undo y times 9 with divide by 9. And I do the same thing on both sides of the equal sign. When I divide both sides of the equation by 9, I get on the left 9 divided by 9 is 1. 1y is just y. On the right, 36 divided by 9 is 4. So my solution is y equals 4. In example 3, I'm going to solve this equation using the same steps that we've used before. When I simplify the left side of the equal sign and the right side of the equal sign, my first objective is to eliminate the fractions. I want to come up with a common denominator for 8, 2, and 4. In this case, the least common denominator, LCD, is equal to 8. Now, I don't actually have to use the least common denominator here. Any denominator that all three terms in the denominator divide could be used. If I had wanted to, I could have done 8 times 2 times 4. 8 times 2 is 16. 16 times 4 is 64. If I had used a common denominator of 64 instead of this common denominator of 8, my final answer would be the exact same. It would change the way my steps look a little bit, but it wouldn't be incorrect. But here, the least common denominator is 8, and so for simplicity, I'll multiply every single term on the left and right side of the equation by 8. 8 times x plus 1 divided by 8 minus 8 times 5 halves equals 8 times 3x plus 5 divided by 4. I went ahead and wrote my numerator and grouping symbols because I know I'm going to have to use the distributive property, and that helps me to remember. If it helps you, instead of just writing 8, you can always think of this as the fraction 8 over 1. It's not a mandatory step to write the denominator of 1, but I find that for some students, it helps them to keep track of what we're doing. On the left side, 8 divides 8 one time to get 1 times x plus 1. 1 times x plus 1 is just x plus 1, and I've completely eliminated the denominator, which was my goal. The second term, I can either cross multiply to get 40 divided by 2 is 20. Or I can cross cancel before I multiply and get 2 goes into 8 4 times. 4 times 5 is 20. And I bring down my subtraction sign to make it minus 20. On the right side of the equal sign, 4 divides 8 2 times. And now I'm left with 2 times 3x plus 5, which I'm going to write in parentheses. So I'm not quite done because I have both like terms to combine and I have a distributive property to execute. First, I'm going to start by distributing my 2 to both of these terms. On the left-hand side, 1 minus 20 is negative 19, leaving me with x minus 19. And on the right side, 2 times 3x is 6x, and 2 times 5 is 10. I now have expressions that are simple on the left and right sides of the equal sign, so I can move on to step 2, which is to add 0 pairs to separate variables and constants. I want all of my variables to be on the same side of the equal sign. Right now, I want to combine this x with my 6x. I do that by creating a 0 pair with the smaller coefficient. My smaller coefficient is 1x, so I make a 0 pair with 1x, which is negative x. I add the same thing on both sides of the equal sign, so I'll add my negative x on the right side of the equation as well. On the left side of the equal sign, x plus negative x is 0. There's my 0 pair. I bring down my minus 19 to equal negative 19, since 0 minus 19 is negative 19. 6x minus x is 5x plus 10. If you had decided to subtract 6x from both sides of the equal sign, instead of subtracting x from both sides of the equal sign, you would still get an equivalent expression. It's just that you would have a negative 5x, and I like to try to keep positives wherever possible. That's why I moved the smallest coefficient. It's not incorrect in the other way, it's just a style choice, and that's the way I like to do it. My next step is to combine my constants. I want to add this 10 in with this negative 19, but since they're on opposite sides of the equal sign, I have to add a 0 pair. I'm going to add the 0 pair with 10 because it's the one that's being added to x, and it's x that I want to isolate. So I add my 0 pair on both sides of the equal sign. On the left side, I get negative 29, and on the right side, I get 5x. Now that I have my numbers separated from my variables, I'm going to divide both sides by 5 to reverse this multiplication by 5. 5 divided by 5 is 1. On the left side, I get negative 29/5, and on the right side, I get 1x, which is just x. So there's my solution.